Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the GRI 194-12-BLK. This is a door position switch is what it is. This is extremely common. This is used in applications where you need to report back to something or to indicate to something, to send a means of communication, which is, it's not communicating, it's either closing or opening the circuit. So in that sense, it's communicating to something else. Where's the position of the door, or at least these two pieces? Are these two pieces together or are they separate? And it would be typical to consider this a door position switch, whether it be installed in the hinge jamb or up in the header or wherever it might be installed to indicate such. Let's take some basic dimensional properties. The overall diameter of the outside part of the escutcheon is about 1 3/16. Its body, it's going to be about 1 inch, and we'll go over the dimensions on this. You've got a bit of a magnet that's in there. Then you've got the opposite side that's here with the 3 wires. Now 3 wires tells you a lot about what type of switch it is, or it may tell you. The length of the leads on this look like they're about 13-inch overall length. Okay, you've got 3 wire colors, white, red, and green. That doesn't really indicate anything other than they're different from each other. The colors themselves don't indicate something, but we're going to be able to determine what those wires actually mean depending on what functionality you need to have and how you'll go about wiring this. So let's talk specifically where a door position switch is going to be used. And I suppose just to finish up the dimensional properties, they weigh about 0.04 pound, so it would take basically 25 of these to make 1 pound, so they're very light. So a door position switch, it's needed in lots of applications. So one installation I can think of all the time where the client says, you know what, I want to sit a neighborhood in Chicago, very busy neighborhood off of Elston Avenue, Elston and Fullerton. An architect has their office there, and there are junior architects and the whole 9 yards. A typical very, very busy Chicago street, bus stop right in front of the building, just foot traffic, car traffic, very, very busy area. They found people were just walking into their office, pull the door open and come in and ask if they had a bottle of water or whatever. They found that because of where it was located, very busy urban area, bus stop, foot traffic, people were walking in constantly. They wanted to lock that door down. Okay, so the client says he's an architect, so he knows what he wants. I want to put an electric. I want to have a doorbell button that when I hit the button, I can buzz someone in. Okay, great, buzz someone in, fine. But the client didn't want the buzzing. The client also didn't have a lock on the door that would work with an electric strike. There was a push-pull and a deadbolt, is what it was, a mechanical deadbolt. Well, that won't, back then, there was no electric strike that would incorporate that. So I suggested an electric deadbolt. Why? Well, it's a simple rectangular body that will get mortised into the header, most likely, or the jamb, most likely, or the door itself, and then the strike will go in the opposite position. The advantage of it is it would be DC, and it would be fail secure, in the sense that, actually, what were we going to do there? It would be fail safe. It would be fail safe, so that during the day, it's energized and locked. Okay. When the power is interrupted, meaning the circuit's opened or someone hits the push button, it cuts the circuit or opens the circuit, allowing the bolt to fail open, which was the design. The logic is, in the event of a power outage, it's unlocked. Great. The only time that would make sense is after hours, when they are mechanically locking the door with that deadbolt. They're going to keep that deadbolt and throw the bolt. It's locked. They would then, the power would be turned off to the circuit so that deadbolt would fail safe, meaning it's unlocked. During the day, that circuit is energized. It's bolted. So when they arrive to work, the electric deadbolt's not powered, meaning it's unlocked. But the mechanical deadbolt they unlock, go in, and then they can initiate power to the circuit in controlling that opening electrically. Okay. That all works, but we're missing something. The problem is, how does the electric deadbolt know when to relock? What if the electric deadbolt, what if someone unlocks the deadbolt, what if the receptionist unlocks the deadbolt, the client opens the door and then stands there for 30 seconds with the door ajar? Well, the electric deadbolt is going to relock at some point. The door will come closed and it won't be able to seat in the closed position because the bolt is projected. Nor do we want the receptionist to, have to stay there with their finger on the button, keeping the circuit open. The answer is a door position switch, where you wire through the door position switch the electric deadbolt functionality such that it will only go to relock when the door has been brought to when the door has been brought to the closed position. Okay, that solves the problem. I also sold the client a time delay so that the door can come fully to the closed position, because there is a gap that's inherent in these items. We don't want it to prematurely start to close. So an adjustable time delay so that the door can get to the closed position, 5, 10 seconds, whatever you want, 30 seconds, then it locks. That is very elegant. And that's what we ended up doing. A single pole double throw, this is a Form C, or a single pole double throw door position switch, door sensor. It doesn't have to be a Form C or a single pole double throw. So we've just introduced some technical terms here that deserve discussion. So you have a single pole, which means there's one common wire. One of these 3 wires is the common. Single pole stands for one of these wires being the common. Let's say it's white. I don't know if it's white. It probably is. It doesn't matter. And I'll show why it doesn't matter. Let's say that's the common. But then you have a double throw. And that's a fancy term for saying, well, I can have an alternating sort of condition, in the sense that you'll wire the common and this other wire, which is unknown, its functionality, or this wire with the common. The common will get one of the other wires or the other of the other 2 wires. It will always get one of the 2 remaining wires. There'll be a common and then 2 other wires. You need 2 to power this. So you always use the common, and then you use one or the other. Now, how you determine one or the other is this. When the door is open, or these pieces are separated, and there might be about a 1/2 inch gap that then it becomes something else. When these pieces are separated, depending on how you wire this, the circuit is either open or closed. So the door is open. Depending on which of the two wires you select, that circuit's either open. Let's just say common and green. Green is such that when the door is closed, there's no power. Green is such that when the door is closed, there's no power. If we were to take the green wire out and bring in the red wire, rewire it with the red wire, when the door is closed, now there's power. So you might want a circuit to act either with electricity flowing when the door is closed, or you might want the circuit to act with no electricity flowing when the door is closed. And that's how you do, and that is the purpose of a single pole double throw switch, because one of these wires is normally open and the other is called normally closed. And then you determine which of those other two wires you use based on the behavior of what you want. We want, in our architect reception area, we want the circuit to be open when the door is open. Okay, the door is closed. We need power to flow there, because that's when they're locking it, unless they throw a master switch and turn off the circuit altogether. The door is closed. That door position switch has to be wired in such a way that it permits electricity to flow. The receptionist hits the button, opens the circuit, the client can pull the door open. Awesome. Door gets closed again. The door position switch goes from a allowing circuit to electricity to flow condition to not allowing electricity to flow until it closes again, allowing electricity to flow. If you had a fail secure lock, in the sense that in the absence of power the bolt was bolted, the door was locked, you might want to switch those two wires. You wouldn't be in a fail secure powering the electric deadbolt at all times when the door is closed, right? Electricity is flowing is how we have it originally. If your lock is fail secure, meaning in the absence of power it's locked, meaning if we reverse those two wires, in that situation power is running continuously. In a fail secure lock, it's always going to be unlocked. Well, maybe that's what you want as well. In a different application, you only want it to be locked after hours. During the day, you want it to be unlocked. Let's say you want people to walk in. You're a retail business. You want them to come in and out. But then only after hours would you change the configuration of that, or want it to be something else, the opposite function. The point I'm trying to make is, without overly making this complex, you'll have a common wire, and then you can either have power continuously or no power continuously when these pieces are either here or here. Here is when the door is open. This is when the door is closed. So you can control it to that degree, and that's what a single throw switch does. It allows you to configure closed and open loop door position switches. And on those, you're only going to have a common and one other wire. And the only thing that's happening is either power flows, power does not flow, or power does. So it's a overly complex description of what this is and why it is, but I suppose after you digest all of that, you say, okay, well, I don't get it right now, but I understand the words. I can either have it powered or not powered, depending on this, and the way you control that is depending on which of the two wires you select. So you can, anyway, not to till the same soil. Let's talk about the profile of the other components of what this is. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Now, this part number 194-12 means something specifically, and let me tell you what it means. Okay, and I'll show you this in a moment. The 194-12 specifically, that part number, is what GRI calls loop type, either open or closed, which is a SPDT, a single pole double throw. So I had discussed the single pole, like a barber pole, and not a door pole, P-O-L-E. We know that that's the single pole. The double throw is the fact that you have two wires here. One is normally open, one is normally closed. In a double pole double throw, you're basically going to have double all of this, where you've got two commons. You've got two commons, and you've got more wires here. You can have each of those on or off, depending on the condition, which simply means you're controlling more than one thing. So an example of that, let's say that the architect wanted to know when someone came in the front of his business, when his receptionist allowed access, buzzed someone even though there's no buzzing. You could have an annunciator which is going to produce a buzzing sound. You could have a light that happens. You could control almost anything electrically with that double pole, double throw, because you're just changing the state of two things when the door is open versus closed. So you could easily do that. Only your imagination limits you in terms of what else can be done, provided the amperage of what that other load is that you are indicating with a double pole, double throw, like an annunciator or a light, or it might be two locks. You might have two locks that you're unlocking at the same time. Who knows? You have to make sure that the amperage doesn't exceed what the gauge of the wires can handle. Okay, so that's mindful. You have to be mindful of that. So that's the 194-12. It means it's a single pole double throw. We also call it Form C. I'm not an electrical expert at all, but if you look up Form C and look at diagrams of what that looks like, it's basically going to look like this, where it goes here or it goes here, here or here. Okay, that's what we call Form C, or is called Form C. I'm not any part of the we. They give electrical characteristics of the maximum initial resistance that can go through it of 0.14 ohm, a maximum contact rating of 5 watts, a maximum switching voltage of 175 volt DC. That is no longer low voltage. And a maximum current, this is the real important part. Maximum voltage, you're never going to run anything higher than 24 volts that I'm aware of. There are 36 volt stuff that exists, but I've never encountered it. Below 50 volts is considered low voltage. You're going to be at 12 or 24 is what you'll be working at. That's important, to not exceed. You're never going to exceed 175 volts in door hardware, to my knowledge. The important part is the 0.25 amp. So whatever you're sucking through, whatever you are powering through this, its switching current can't exceed a quarter amp or 250 milliamps. Otherwise, these wires are not intended for the job. You need something that will handle more amperage. And an annunciator, an LED, these things are not going to get close to a quarter amp. So you would power that. You obviously have to power it through here. An electric strike, you'd have to, that electric deadbolt, you'd have to look at that and say, is this the right rating on the wires for the load that the electric deadbolt is going to be asking for? And I think the one we installed was about 180 milliamps, something in that range. It was below the threshold for the door position switch that was used. Now, why don't we take another look? Let's do another camera test here, and we will get the multimeter out and we'll play with these wires and discover what is what. Common, normally open, normally closed. Let's do that now. Okay, let's discover what these wires are all about. And you're going to need a multimeter for doing this. Multimeters can be expensive and they can be really, really inexpensive. This is a really, really inexpensive one. $20 or $30, believe it or not. I actually got it for free being in a class that I was in, so I keep it at work and I use it for demonstrations like this because it's really simple and straightforward. It will have a power button. Look at us. Okay, we'll be able to see this. Now, on the dial, you want to set this for continuity because all you're going to do is you want to test the path of the very tiny amount of voltage that you'll send through here. Testing for continuity allows you to know what wires do what, but also probably more commonly used to determine whether or not there's a break or an open in a circuit. If you don't get continuity through it, then when you have your leads on two ends of the wire, you'll know that you have an open, not a short but an open. So continuity is this little gizmo here, this setting. It's got a little, I don't know, what I would call a horn on it, and it will literally make a sound. It will give a buzzing sound when you know that you have continuity, and you won't have a buzzing sound when there is no continuity. So right now, these two pieces are separated. This would be a door closed position. This, we're going to put this, we'll put that over there. And all I'm going to do is I'm going to put my, it doesn't matter what color you put on what wire, you're just testing for continuity. So I'll put one lead onto the white wire, then the other lead onto the red wire. Now you hear that. We have continuity between the red and the white wire. Interesting. Let's take that step. Let's take that a step further. Let's take that a step further. I don't have my alligator clips close at hand, which is what I would want to use. But I'll use these paper clips. We put, hopefully this won't be too tedious to watch me do this. That'll work. All right. Well, we'll hope that makes contact. Then we went black to red, I believe. Yeah, we have continuity. Okay, you can hear that. This is when the door is open. Well, obviously the door is open because this part is over here. Watch what happens when I bring this. The circuit is closed. Electricity is running right now. The circuit is open. There is no electricity running. So, if we were to want to test this theory of what we were talking about earlier about you can control it depending on which wire, let's now go to the green. I don't get any buzzing. Now it's the opposite condition. I only get continuity when the door is closed. When I open the circuit, I'll cut power to the deadbolt. The customer can now pull the door open. The door opens, circuit is turned off. There's no power until the door comes back and closes again, where it's energized. I'm saying add a time delay first so that it holds, even though the door is closed, it won't allow continuity to resume for 5, 10, 30 seconds, whatever you want. Now, I had picked the white wire as the common. I picked that because, you know, it's common to see, it's typical to see the white wire as common. So, let's see if I was right, because we can determine that. Let's remove our probe from the white wire and put it to the red wire and see if anything happens. Now we're connected green and red. There's no continuity. There's no continuity. When it's dead like that, when you don't get any alternating action, you know that you've got the wrong wire as common. So you will always be able to determine with a simple tool and this approach what is the common wire, because you'll either get observable behavior changes when door closed, door open, or you won't. And if you don't get observable behavior, swap out one of your wires for the other one, and at that point you're probably going to be on the trail of finding your common wire. You have to know what is common. It wasn't just a guess that I picked white, although it could have been, but I proved that it was white. Right, what I'm doing right now. If I were to switch my two leads, I get the same problem. There will be nothing that happens. So that's continuity, and that's how we know what we're wiring, because at a certain point the person installing this material is going to have to select two of the three wires and is going to have to wire them, and that's how you go about knowing which is which. Okay, let's switch now to the screen view and let's take a closer look at the supporting information. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. All right, here's the item that we are looking at in terms of its cut sheet. And on page 2 of the cut sheet, it's going to give us some important information. Let's look at page 1 first. So we are working on the 194-12. Okay. Single pole double throw. Standard gap up to 1/2 inch on steel. Gaps will increase substantially for installations on doors other than steel because there's less interference on wood or fiberglass. So 194-12. Well, how does that differ compared to a 190-12? Well, the size. We're dealing with a 1-inch diameter. They do make smaller ones, 3/4 inch diameter. WG are wide gap. That means if you've got an installation where the gap between the door and the jamb, or whatever it is, needs to be wider because you can't bring the two pieces closer together, you might want to consider a WG. Closed loop, open loop, single pull double throw, double pull double throw. Page 2 that I had just mentioned, the table that's here, 194-12. It's an open or a closed loop because it's a single pull double throw form C and those electrical characteristics that I mentioned earlier. And everything here gives you pretty much everything that you need to know. And again, you don't need to know which wires are which wires because you can now identify them in the field. And these are 22 gauge wires, is important to know as well. We have some images here. When you buy one, that's what you're going to get. Press fit into the steel frame. The back side of what would typically be the door portion. And that's what it looks like. Very thin profile here. Shouldn't give you any trouble at all with gaps between doors and frames. Now, there is a link below this video as seen here to the manufacturer's page. And from here you can pull up not only all of the GRI products that we sell by means of this horizontal navigation as seen here, but also a link to the manufacturer's website, as well as a link to the product catalog, and I would recommend diving into that, as it will allow you to review all things GRI related. 278 pages worth of material. That's a lot of electrical components. I don't spend a lot of time going through this catalog. But if you're looking for door contact position switches, things of that nature, you may want to dive into this. They have a variety of items here. They also have items, we mentioned the 1/2 inch gap or 3/4 inch gap. They also have versions of this that tolerate a far smaller gap only, and there's a term for those types. That I don't recall. There might be a security type is what they may be called. But that gap is very, very small. And you would want that. You don't want people to try to defeat a door or a window by being able to make a movement of, let's say, 1/4 inch without triggering the door position switch. And the term biased comes to my memory. So let's search for biased. Yeah, biased high security such switches overview. Let's take a look. Biased for high security. So what there's a technical definition to what that means. Yeah, you can read here in terms of how it actually works. Yeah, so basically what it is during the manufacturing process they alter exactly how the magnet is positioned on the inside of the switch so that any movement of either piece will instantly trigger the condition, so to speak. So there you go. We don't sell these very often, but applications that require it are sure gonna be looking at biased high security switch sets. All right, let's wrap up this video on camera. Well, as I had mentioned earlier, I don't go through that catalog very often, and it's really because I don't have a need to go through that catalog very often, in the sense that door position switches, which we sell, rarely require me to dive into variants other than kind of what you see here. Sometimes it's the 3/4 version, sometimes it's a different color, but it's almost always single pole double throw. Can they be what I think are Form A, just single pole single throw? Don't quote me, I don't remember if it's Form A, it might be. So I don't have cause to go into the catalog very often. But I can tell you this, I have called George Risk Industries a half a dozen times for tech support, and they have always and without exception provided me extremely accurate, extremely thorough, extremely kind bedside manner. They're experts at what they do, and they are eager to help you wade through the confusion in terms of what is open loop and what is closed loop, and they do a great job at it. If you're doing door position switches, look to their product line, because when buying from them, which is in my experience the most economical way to purchase this material compared to other names that are put on door position switches, but you're going to get the backing of exceptional technical support as well. So any questions on the 194-12, and they're sold as each. This happens to be a bag of 10. Any questions on the 194-12 in a black or any other? I'm sure they're available in white as well, since I have the catalog open and the film is rolling. I'm corrected. White, brown, gray, black. There you go. Might be multiples of 10 that you have to order when you do something that may not be stock, but nonetheless, lots of color choices. So any questions on this or any other GRI product, please feel free to reach out to us. And thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.